Hi, I'm Laura Nickerson.
I'm Mr. Radford.
And welcome to the Viking Science Academy. Today is your second chemistry lecture, so you should have already watched the first one and done learning checks. Today we're going to talk about atoms and how they're built. So how do you know what atoms look like, Mr. Radford?
Well, there's scientists who have done a lot of studies on them. We really don't know exactly how they look like.
They're too small to see.
Yeah, so we set up models to try to help us understand it.
Okay, so this brings us to something called the atomic theory. So it's basically what we believe about atoms, that every element is built of atoms, and that atoms of each element are similar but not exactly the same, and that each element, the atoms are different from one another. So gold is different atoms than silver. And if we get those two atoms to bond together, we can create a compound. We're going to take a look at what this model looks like in class, so if you need to, you can go to YouTube and rewatch that video. What are the three particles of an atom?
So we got protons, neutrons, and electrons.
Okay. Tell me about an electron.
So electrons are electrically negative charge. Okay. They have such a small mass. They have a mass, but it's so small that we call it zero.
Okay. Because everything has mass then.
Everything has to have mass.
Gotcha. Okay. So protons and neutrons are found inside the nucleus of an atom in the center, and protons have a positive charge. Pro means positive, and they have a mass of 1, and neutrons are neutral. They have no charge at all, but they have a mass of 1. So overall, we have -1 from the electron, +1 for the proton, and so that atom has a neutral charge overall. So we talked about how the electrons sit outside, or we're talking about it, how they sit outside of the electron. Now in this picture it looks like they're kind of close, but in real life they would be super far away. Like they wouldn't fit on the screen, they wouldn't even fit in your room. They're so far away from the center, the nucleus of the atom.
And most of the mass is in the nucleus, and so like the nucleus, the size of it is about a pinhead. If we put a pinhead in the middle of a football stadium, that's about how big the nucleus would be. Really, so most of an atom is empty space.
Empty space. Okay. So how do we know how many protons, neutrons, and electrons an atom has? Well, we look at our periodic table. We talked about how it's organized very specifically. Well, one of the things that it's organized by is its atomic number. An atomic number tells us how many protons there are. So find sodium on your periodic table. You'll see there's number 11 on it. Now there's also another number there, so you have to understand which one you're talking about. And some periodic tables have the atomic number on top, and some of them have it on bottom, which is kind of confusing. Just know it's the one that goes up by 1, right?
Yeah, and ours is set up, and it gives you a key on carbon, and so it's the number in the upper left-hand corner. It's the atomic number.
So that must mean that the atomic number tells us the number of protons. So therefore, sodium has 11 protons. Okay, well you can take a second and you can look at some of the other ones. We got a learning check. Make sure you know how to find the number of protons for different atoms on the periodic table. What's this other number? What does it count?
It's the atomic mass, it's the atomic weight. Each periodic table kind of says things differently, and that's the number of protons added to the number of neutrons. Okay,
so it's kind of like its total mass, since protons and neutrons both have a mass. So looking at sodium again, that number 23 means its mass is 23. So the protons plus neutrons must be 23. Well, I might be able to do some really quick math and figure out the number of neutrons too, right? Yep. I could maybe subtract it from...
Yep, that's exactly
All right, there's some pretty easy stuff here. So here's that math there. If I know the total mass is 23, I know that it's the number of protons, which is 11, plus the number of neutrons, x. I can solve for x and figure out that sodium has 12 neutrons. Pretty simple math.
It is.
How do we know how many electrons an atom has?
Well, on our chart, it says with the atomic number, the number of protons is the same number as the number of electrons.
Because the overall charge is 0.
Yep.
So you have to have plus and minus the same. Okay. Yep. It's good to know. So here's some examples of us picking 3 elements like oxygen, and we can figure out how many protons, neutrons, and electrons it has. They're not always the same. Sometimes that just works out that way.
Yeah.
You actually have to do the calculations to figure it out. So we'll pause here just for a second. Hang on, don't leave yet. Let's take a second and talk a little bit more about electrons. We know they have such a small mass that it's a 0. They're located way outside the nucleus, and they travel at crazy high speeds. I tell my class they're traveling so fast, At any time, if you were on the outside trying to reach in and touch the nucleus, no matter where you punched, you would always hit them. Because they're kind of like they're everywhere at one time.
Yes, and that's why I said that the atoms, we don't know exactly how they're set up because of the electron.
So these electrons sit in what we call energy levels, or clouds if you want to call them too. We can measure these based upon spectra when we get different atoms to bounce off one another. And these levels allow the electrons to jump to different energy. If they jump further away, it's going to change as when they fall closer to the nucleus. And so going further away, they're going to jump to a higher energy level, kind of like going higher up a ladder. And when they get closer to the nucleus, they'll actually give off energy, so they jump to a lower energy level. And that's how we can do stuff like atomic bombs and nuclear energy. We can capture that energy. So it's pretty easy to figure out. Going up, you gain energy. Dropping down, you lose energy. Where does this come from?
Well, it comes from a scientist named Bohr. What a name.
I know.
Could you imagine that?
Mr. Bohr. That would be rough.
So he kind of set up the first electron structure, and he puts these, basically the electrons, in different shells. Shells, energy levels, those are kind of interchangeable. So
I understand it's not quite perfect, but
no, it's not.
Makes it really easy to understand, and then we can build on that knowledge for later. Okay. So this leads us to the study of quantum mechanics, which is basically the energy levels or shells of electrons. And if they're in a specific level, then they have the same energy as the other electrons in that level. And so we say our lowest energy ones are near the nucleus, and then they move out. So we can say this is the first energy level, the second energy level, the third shell, the fourth shell, however you want to take a look at it.
And if you remember the periods, okay, these all have the same number of shells going left to right. And so 1, 2, 3, 4, 5, 6. So the periodic table is set up to kind of show that as well.
Yeah. All right. So how do we know exactly the number of electrons? Well, remember, you can take the number of protons, and that's going to tell you the number of electrons. There's a formula, 2n2, but you can also just kind of know that there's a pattern, and you can count it out as well. So you don't need to know that 2n2 so much. But you need to know how many electrons go in each level. So the first energy level will only hold 2 electrons. What about the second energy level?
Second energy level can hold 8 more, okay, but the first shell has to be full first.
Okay.
2 there, and then up to 8 the next one.
So I kind of tell them like it's a car. The first car only has 2 seats, and anybody new gets bumped to the second car, and the second car only has 8 seats, and then they just keep bumping out. Now the third shell has 18, but we first count 8, and then we add the 10 on later, and we'll explain that a little bit more in class. Here's basically, in general, what it looks like. You can see the 2 electrons around the nucleus in the first energy level, and then 8. Then it goes to 18, but we know that there's 8, and then 10 later, and then 32. And so you should be able to figure out how many electrons there are and in which energy levels there are. So let's take a look at helium. Helium on our periodic table its atomic number is 2. So it has 2 electrons. Well, it's going to be pretty happy because all those fit in the first energy shell. But carbon, one of my favorite elements, has 6 electrons. So only 2 will fit in the first shell. Where are those other 4 going to go? They're going to go into the second shell for a total of 6 electrons. So you can practice this with some other elements, and then also you should be able to perform this on a learning check and do it on your own and tell us what they are, or even maybe draw it out, or maybe use some candy like we're going to maybe do in class later on. Okay, so perform your learning checks, and this is another way that we got groups on our periodic table as well. So we looked at the number that are in the last electron shell, and that's what led us to some of our groupings. All right, so you can take a look and see if specific elements have similar chemical properties based upon their last electron energy level. All right, well, we'll see you guys in class for some electron energy level activities, and you should be able to
building some atoms.
Yeah, maybe split an atom here and there. You might need to watch this one a couple times to understand it, and make sure you do the learning checks. Thanks for joining us on the Viking Science Academy.